If you try demo 2A yourself, you'll notice that some of the keys work, some others don't. That's because the resistors that you have used with their exact actual values rather than the advertised ones, and the formula that is used in that sketch very much connected with each other. They have very little tolerance for error. So some of the keys in your case probably are not working, just like that didn't work in my example. The lesson to take away is that although the solution is elegant, where a single calculation encapsulates the key detection logic, we have too many dependencies to worry about, and that those dependencies are out of our control to calibrate. So in demo 2, let's go ahead and try out a solution that, although it's less elegant, it allows us to calibrate our circuit for the resistors that we have in hand. I use resistors with advertised values as in the resistor table that is available in the notes, but without the expectation that they are perfect. In the demo 2B, I will show you how to deal with these variations and how to calibrate the circuit so that each key press is identically and correctly identified by the Arduino. Well, here's another script. This one is not as efficient in terms of size, at least. It's a bit dumber because we don't use a fancy calculation to do the job of determining what key has been pressed. But what we do now is we can calibrate this logic a lot easier, a lot simpler than the previous formula-based logic. So what we're doing is saying if the voltage produced by a particular key press is between this value and this value, then the key that was pressed in this case was 1. If the voltage produced was between this value and this value, then the key that was pressed was that, and so on. Let's start it. Have a look at the monitor. And let's press a few buttons. As you can see that pressing number 1 produces pin value 843. Number 2 produces 737 and 736. So that's a range of values produced. Press a few times to make sure that that's a range. So that is actually the range, like 737 and 736. Number 3 produces 641 or 640. A few times to make sure. Oh, there's a 636 down there. So that's a range. A produces 599, 598, so on. Star down here produces 270 and 271. D 244 and 245. There's a 243 as well. Yeah, all right. So then what we go and do is go to the read keyboard function and encode all these different possibilities and ranges against each number. So for example, when I press number 1, it's 843. 842, 843 is maximum, 842. So I'm going to replace that. Get my keyboard. 842 and less than 843. And then the key that was pressed was 1. So do the same thing for a couple more keys. And I'm going to do, let's say, the star down here. So that's 270, and there was a 271 in there as well. So I'm going to copy that because there is no star yet. Here. So can you make that a star? So 840, sorry, 270 and 271. And I will do one more, maybe pick the B. So press the B key, and the range is 417 and 418. Seven and 418. Okay, I'll leave the rest for later. Oops. I have made a mistake because key pressed is declared as an integer. I should turn that into your character. And I don't really need the numerical versions of these numbers, so I'm going to use double quotes to turn them into characters. Right, and I'm just going to comment out everything else since I don't need it right now. So number one. Not outputting. There you go, read keyboard so that we can see the actual symbol of the key that was pressed. So output again. Okay. Should be 845 for number one. All right, there you go. So sorry about that. So now when I press number one, reading comes in as 844, which is within the range of the character number one. And for key B, it's 418 and 417. 418 should make that 9. So that, because I don't have the equality symbol in my test here, so the 419 and 416 are not inclusive. So I'm going to make that 69 and 72 to make sure that 271 in this case is within the range for the star symbol. So I upload it. So B, C comes out as B, star comes out as star, 1 comes out as 1. So there you go, that's how you can just use a single data pin in order to connect your keypad to the Arduino. You are going to have, depending on your own setup and the resistors that you use, to fill in the rest, which I'm going to do a little bit later as well. Okay, just like we showed you. The other nice thing about this script, this sketch, is that it's not depending on a library. So you don't have to use the built-in or a third-party library. You just read the voltage in analog pin 0 or whatever analog pin you have available. In this lecture, you learned not only about how to connect a keypad to your Arduino, but also gained some skills in calibrating your project to match exactly your specific configuration. He also discovered that there is a range of possible solutions to the same problem and that solutions differ in terms of elegance and practicality. I think you are now ready for your most challenging exercise to date. For this project, you will need a keypad, an LCD screen, a light intensity sensor, photoresistor, a DHT22 sensor, and the Arduino. Build a project that combines these components and works like this. If the user presses key 1, the LCD screen displays the temperature. If the user presses key 2, the LCD screen displays the humidity. If the user presses key 3, the LCD screen displays the light intensity. And finally, if the user presses key A, the LCD screen will say hello.